Okay, so hi and welcome. So can you hear me?
Yes.
Okay, so just we are waiting some 1 or 2 minutes, then we continue our today's class. Okay, so we will start our today's class. Okay, so I simply share my screen. Okay, so now can you see my screen? Can you see my screen?
Yes.
Okay, okay,
Yes.
okay. Okay. So hi and welcome to the 7 days online training program on Google Earth Engine for remote sensing analysis for beginners to advanced. So basically, we already cover our first day, and today is our second day. And this second day's course content will be that. So this is our overall full course content. We try to complete all of the topics within the 7 days. And today is our second day. And second day's course content will be that. Today I will try to show you this part, how you can easily filtering and displaying the satellite images, Landsat and Sentinel. Suppose you want to need a Landsat image for any specific region, any specific time period, how you can easily filter the satellite images and get the satellite images for Landsat and Sentinel. Okay. Then how you can easily use the different types of band combination using the satellite images in Google Earth Engine platform, and how you can easily export the satellite images from the Google Earth Engine platform. And when you want to export the satellite images, and you can easily work with the satellite images for the different types of other types of geospatial software such as ArcMap uses, ENPI or other software. Then we'll also try to discuss about that how you can easily import, filter, reduce, clip and display data in Google Earth Engine. After this, we also try to show you that how you can easily make the time series NDVI chart, as well as how you can easily export any shapefile and calculating any indices from the satellite images. Okay, so let's go at today's class. So first of all, Earth Engine public data catalog. So mainly we are getting all of the remotely sensing data from this Earth Engine public data catalog. So when you want to use the Google Earth Engine platform, you don't need to download any types of satellite image. You don't need to download. It can be Landsat, Sentinel. We can get the different types of Landsat image collection, Sentinel image collection, raw image, top of atmospheric image, surface reflectance satellite image. All of the things we can easily get from the Earth Engine public data catalog. And we can also get the some MODIS data set such as daily, NDAR, LST data set, or a lot of data set will be available in the MODIS, as well as also train, land cover, atmospheric data set, and more way. And there are a lot of data set, and these data set updating daily. In the public data catalog, here we can find out more than 200 public data set. Just a minute, I think someone also joined, so I simply approve. Okay. So basically, in this Earth Engine public data catalog, here we can find out the more than 4,000 new images every single day, and for more than 5 million images, as well as we can also find out the more than 5 petabytes of data. And this is the main website for Earth Engine public data catalog. Mainly from this link, we can get all of the Earth Engine public data set. Okay. So basically this link we can also get from the Art Engine code editor. So I simply open the code editor. And then you can see this is our top of the code editor. This is the search place and search dataset. I simply click to here and you can see browse data catalog. Browse data catalog. So in this time I simply click on the browse data catalog. Then I can get this link, Art Engine dataset. So I can get all of the dataset here. You can see. So here I find out all of the dataset. It can be surface temperature, climate, atmospheric, weather, different types of landscape, sentinel imagery, MODIS, high resolution, different types of terrain dataset, land cover dataset, cropland. Okay, so a lot of dataset is available in here. As well as also you can see when I click on the Landsat, so here I find out the all of the Landsat image collection. Landsat, all of the Landsat collection. You can Landsat 9, Landsat 8, Landsat 7, Landsat 5, Landsat 4, Landsat 1 to 5. Okay, as well as also you can see Sentinel. So here I can get all of the Sentinel image collections, such as you can see Sentinel 1, Sentinel 2, Sentinel 3, Sentinel 5, as well as also some dataset, which dataset derived from the Sentinel 2 satellite imagery. Okay, so dynamic world as well as ES world cover. Okay, we can also get this dataset from the Sentinel. Okay, this dataset is the derived from this Sentinel 2 satellite Sentinel imagery. Okay, in this time you can also see the MODIS. So here I can get all of the MODIS image collection, different types of daily products, derivative products, all of the things we can easily get. Here you can see all of the dataset. Which dataset you want to need, you can simply import the dataset in a code editor and you can easily work with this. So there's a lot of dataset. Here you can see the Terra cover daily Landsat, Terra land surface temperature. A lot of dataset is available in here. Okay, all of the dataset for importing, for filtering, for reducing, all of the things will be same. Okay, so in this time from the MODIS, I try to show you only for the one dataset, but you also try to use you can just follow the process and try to make the map for others dataset. Okay, suppose in this time I try to show you the result for this I use the dataset such as okay, so I use the dataset vegetation index is 60-day global 250-meter resolution. So in this time I use this dataset and try to make the NDVI map for any specific region. Okay, so in this time I use the dataset, but using the same process you can use the same process for making the any types of dataset for making the map, such as evapotranspiration map, gross primary productivity map. So all types of dataset you can just follow the same process. Okay, so first of all I simply open the dataset. So when I click in here, now it open my dataset. Here you can see. So I can get the dataset availability date. You can see we can get the dataset between this time period. Okay, and the dataset provided is that, and this is the Art Engine snippet. So mainly Art Engine snippet is that unique ID. So it's a unique ID of this dataset. Here you can see it's a unique ID. Okay, so every dataset has a unique ID. Okay, so in this time I use here the MODIS vegetation index is 60-day global 250-meter resolution. This dataset and this dataset, and this is the unique ID. Okay, so every dataset has a unique ID or Art Engine snippet. As well as you can also get the description about this dataset. Okay, as well as also you can see band. So mainly this dataset provide you the two band, NDVI and EVI, normalized difference vegetation index and enhanced vegetation index. It's provide. As well as also you can see all of the details about this dataset. So in this time I use the dataset and try to make the NDVI map for my own country, Bangladesh, or any other region. Okay, so for this, first of all I need to import the dataset in my code editor. So this is my code editor. This code editor I need to import my dataset. So I can import the dataset in my code editor two way. If you want, you can simply search here. I simply search here MODIS NDVI. I simply search. So now it suggested all of the dataset for the MODIS NDVI. I want to use the dataset. You can see 16-day global vegetation is 60-day global 250-meter resolution. This dataset I use. So here you can see I can get the same information also here. All of the information will be same. Okay, so if you want, you can simply search in your top of the code editor, this search box. You can simply search the dataset name, then it will be appeared. Okay, then you can get all of the things, description, bands, term of use. You can get all of the things. Okay, also dataset availability, dataset provider, Art Engine snippet, all of the things I can get. In this time, if you want, you can simply click on the import. You can see import. This dataset is the imported in your code editor. Okay, so now this Modis NDVI Modis dataset is imported in your code editor, and its the default variable name is the image collection. If you want, you can use any variable name. There is no problem. Okay, so this is the one way. Another way is that you can simply copy. You can simply copy this Earth Engine snippet or this Earth Engine unique ID. Simply copy and then paste in your code editor. So I simply paste in my code editor. Okay, then I simply give a variable name. So before the variable name, you must be using the var keyword and then put a variable name. You can put any variable name. So I simply use a variable name such as, suppose I simply put the variable var keyword and put the variable name is the suppose Modis. Okay, you can put any variable name. So here you can see that there are the two ways for import the dataset in your code editor. If you want, you can simply search the dataset top of the code editor and click to the import. This dataset is imported. Or you can simply copy the Earth Engine snippet from here and then simply paste in here, and then you can simply give a variable name. Before the variable name, you use here the var keyword. So this is the another way for import the dataset in code editor. Okay, so you can just follow only one way. Which is better, you can simply follow the way only one. So in this time I use this way and simply remove this. Okay, so now you can see this dataset is imported in my code editor, and my variable name is the Modis. Okay, so now my full image collection, this is my full image collection. This full image collection is stored in a variable Modis. Okay, and this image collection has a two band, NDVI and EVI. Okay, in this time I want to work with the NDVI, not EVI. Okay, so that's why from this image collection, all of the dataset, I need to select only for the NDVI band. Okay, so for this, I simply take a variable name and give the variable name is that you can put any variable name. I simply put the variable name is the Modis NDVI. Okay, you can put any variable name. In this time here you can see this is my image collection. Okay, and this image collection has two band, NDVI and EVI, and this whole image collection is stored in a variable. This variable name is the Modis. Okay, so I simply copy the Modis because my full image collection is stored in the Modis. I simply paste here. From the Modis, I need to select. I simply use here the select function. Select a specific band. I want to work with the NDVI band. So I simply copy the NDVI and then paste here. Okay, so now you can check. This is my full image collection. This image collection has the two band, NDVI and EVI, and this image collection is stored in a variable Modis. So I simply call the Modis. From the Modis, I select only for the NDVI band because I want to work with the normalized difference vegetation index. Okay. Okay, so now let's check how many images are available for the NDVI for the whole world between the time period, this time period, year of 2000 to 2022. Between this time period, how many images is available? So for this, I just simply use here the print function. Sorry, I simply use here the print function and then simply call the Modis NDVI. Okay, because you can see this is my image collection. This image, from this image collection, I select only for the NDVI. Okay, and all of the things I store it in a variable. So I simply call the variable and paste here, and I simply use here the size function. So size is a function. It's determine how many images are available in this time. So I simply click to the run. So now you can see I can get total 521 images. Okay, for the between this time period. Okay, in this time I not work for the whole time period. Suppose I need the NDVI dataset only for the 1 year or any winter season or rainy season or any time period. I want to need this NDVI dataset. Okay, so for this I can easily filter my specific time period. Okay, so for this I simply take a variable. Suppose I simply put the variable as a filter. You can use any variable name. You can see 521 images is stored in a variable. This variable name is the Modis NDVI. Okay, from these 521 images, I need to filter only for those images which images are available for the year of 2021, or which images are available for the rainy season of 2021. So any time period you can easily filter. So I simply copy and paste here. Sorry, I simply copy the variable name. Just a minute. Okay, so I simply filter. I put the variable filter date. Okay, filter date, and then I simply call the modis ndvi because it stored total 521 images, and from this 521 images I need to select only for the specific time period image. So I simply use here the filter date. Suppose I want to work with the for year of 2021 suppose 1st January from 2021 December 31. Okay, so this is my time period. I want to need only for this data set between this time period. You can easily change your time period, which time period you want to need. You can simply put the time period. In this time I want to check how many images are available for this time period. I simply use the print function, print, and then I simply call the filter date and use here, and then I simply use here the size function. Okay, and click the run. So now you can check how many images I want to get. I can get 23 images. Okay, if you want to check what is the time interval between the one image to another image, I want to check it. First image to second image, what is the time interval? I want to check it. So for this, I simply copy the I print function and simply call the filter date. Just copy the video and paste here and click to the run. So now you can check. I get the every satellite image between the first image to second image. This time interval is that 16 day. You can see first image is that 1st January, then 17th January, then 2nd February. So each image you can see time interval is that 16 day. So that's why this dataset called here the 16 day global. When you want to get the dataset 8 day global, it means that this dataset interval first image to second image, this interval is that 8 day. When you can get the 32 day global, it means that first image to second image, this interval is the 32 day. So here you can find out the lot of data set about the 16 day, 8 day, 32 day. Okay, then you can easily identify. It means that interval, time interval. Okay, for the first image to second image, first image to second image. Okay, so in this time here I can get total 23 images, and you can see this total 23 images is not captured or it's not created at the same time. Okay, so you can find out the every 16 day global interval time period. Okay, so in this time it's reduced. I need to reduce this image collection. Okay, I need to reduce this image collection. So for the reducing, I want to use here the min function. Suppose in this time from the 23 images I calculated all of the images average pixel value. Okay, I calculated the average pixel value and then create this map for the 1 year NDVI map. Okay, so for this I need to use here the reduce function. So reduce is an statistical function. So mainly when you want to calculate the mean, median, mode, as well as also standard deviation, then we are using the reduce function. Okay, so let's go. In this time I want to reduce this all of the image collection, 23 images. I just reduce. So for this I simply take a variable. Suppose this variable name is that average NDVI. You can use any name, no problem. Then I simply call the filter date because this 23 images is stored in the filter date variable. I want to use the total 23 images and calculated the average pixel value of NDVI. So I simply copy this name and paste here. In this time, these 23 images I want to reduce. So I simply use here the reduce function. Then how I can reduce? I want to reduce using the average. Okay, so I simply use here the ee dot reducer dot mean. Okay, so in this time I calculated the mean result of the total 23 images, okay, and stored it in this variable. So let's go. I want to show the display on this map. I simply use here the map dot add layer and then call the average NDVI. I simply copy and paste here, okay, then click to the run. So you can see this is my object I want to show in this time in my whole world NDVI map. But this map is not good because I did not add any visualization parameter. So that's why I did not understand where the dense vegetation, where the low vegetation. I did not understand because I did not use any types of visualization code in here. So in this time I need to add here the visualization code for better identify the which region is the better vegetation, which region is the low vegetation, like this. So in this time they already provide a demo code, okay, in this for this data catalog page we can find out the some demo code. So I simply copy their demo code, color code. So in this time I simply copy this code from here and then I simply paste here. So in this code here you can see they are mainly make a dictionary. So they are using here the curly bracket, okay, and their main here you can see they are use here the value mean. So this is the keyword and 0. It means that in this time this map getting the visualization of NDVI pixel value minimum it will be start from the 0 pixel value and up to 8000. Between this range we can get the NDVI result, okay, and according to the range they also add here the some color plated, okay, and they also make a list in here for the color plated, you can see, okay. So I simply copy the variable name and we already know about that. After the object name, this is the object name, after the object name we always put here the visualization, okay. So in this time I simply put the visualization variable name, then click to the run. So now you can check I can get the whole world NDVI map for year of 2021, okay. Very few minutes, very few seconds we can get the result, okay, and we will identify, okay, you can see, okay, where the vegetation is high and low you can easily identify, okay. So in this time you can see this map I get for the whole world, but I don't need for the whole world, I need only for my own region or any specific region or my any country, any specific country I need the result, okay. For this you can easily, and previous class we also try to show you this part how you can easily import the shapefile. We already discussed about this part, as well as we also try to show you the dataset for US DOS. This dataset, mainly this dataset provide you the international country boundary polygon. So in this time I use the dataset and get my country boundary shapefile from the dataset. So for this I just simply take a variable, give the variable ROI, and then use here the I simply use here the modis. Sorry, I simply call the table. I simply copy the table and then I simply filter it. So I simply filter and get my specific country boundary shapefile. Filter equal what's equal what? I simply put here the country name. Then I simply put here the suppose Bangladesh. Okay. So now you can see this ROI is stored at the Bangladesh country boundary shapefile. Okay. So in this time, average NDVI is showing the whole world NDVI map, but I don't need for the whole world. I need only for my country boundary shapefile of Bangladesh. So that's why I need to clip with my shapefile. Okay. So that's why I simply take a variable. I simply put the variable name is the suppose study area. Okay. And then I simply call the average NDVI because it is stored the whole world. But in this time I don't need for the whole world. I need clip with my shapefile. So I simply call the average NDVI and then I simply use the clip function. It clip with my shapefile. What is my shapefile variable name? ROI. Okay, because you can see Bangladesh is stored at the ROI. I simply copy and then I simply paste here. Okay, in this time this is my final object. I want to show the result only for the country boundary of Bangladesh. I simply copy and paste here. Click to the run. You can see I get the result, but this result is not focusing, center focusing. So in this time I use here the another code for the center focus of the shapefile. So I simply use here the map dot center object, then call the ROI. Okay, then I simply put the zoom level to 10 and click to the run. So now you can check, I can get the center focusing of the shapefile of the NDVI map. This color is look like this because this color is the default color. Okay, if you want, you can also rearrange the color. Okay, it's totally different on you. So I'll also try to show you this. In this time, I can get the NDVI map for this, like this map of Bangladesh. Suppose I want to need this map for the another country. So I simply put the country name. Suppose as Saudi Arabia. Now I can get this map for the Saudi Arabia. I can see. Okay. So now I can get what is the condition of the Saudi Arabia NDVI map year of 2021. So very less vegetation in this region. You can see. Okay. You can find out some vegetation in this region. Also some region. Okay. Also some vegetation. Suppose I need the result for another country. So just you can simply change the country name. Suppose I need the result for Australia. I simply use here the Australia. Now I can get the result for the Australia NDVI map. So any country we can easily get for the NDVI map. Okay. In this time, you can say I can get this map, but this map has a problem. What is the problem? This problem is that when I click on this inspector tab and click on this map, you can see I can get the result 1378. Okay. But we already know about that NDVI result, this range between the -1 to +1. Okay. But in this time, it's not appropriate. Okay. So when I click here, you can say I can get the result look like this 3861. But this result will be -1 to +1. Okay. So in this time, my main target is that I reprojected this scale value so that I can get the result, this range -1 to +1. So in this time, anyone any question about this? You can ask me. Anyone any question for this? Anyone any question?
Yes, I have one question.
Yeah.
So why are we calculating the mean value like from the 23 image?
Okay, so here we can find out the total 23 images for the 1 year, and this image is not captured at the same time. Okay, so different time it's captured. So in this time, I need to reduce this image collection. Okay, so in this time, we are getting the average. Suppose you can see, I simply share you. Suppose you can see for a console tab, 23 images I want to get from here. Suppose you want to check, you can see every images you can get. Suppose you can see this is the unique ID of this image. So this is the first image, and this first image you can check it. This region is the your region is covered or not. Okay. Suppose suppose your region is the Bangladesh. So when you want to use this only for this time image, suppose year of 2021, 1st January is not covered because Bangladesh has a big region, and there are a lot of tiles, lot of satellite tiles cover the whole Bangladesh. Okay. So when you want to work with the small region, which region is the only cover only for the single tiles, then it's also okay, no problem. You can use the simply copy this ID, image ID, and use it. Then you can get only for the NDVI map for the year of 2021, 1st January. Okay, but when you want to work with the big regions such as Australia, Bangladesh, Saudi Arabia, then it's not possible. Only for the one satellite image is not covered the whole region. Okay, then we need to move to the reduce function, and we can calculate it all of the 23 images average pixel value and calculated this NDVI. Okay, and it's also cover our region. So when I want to talk with the Landsat, filtering the Landsat image, then you can easily understand about that. So because when I want to talk about the Landsat image, then I also try to show you that every single day image how we can easily get. Okay, we can check that some single image is not cover my region. Okay, some single image also cover my region. When it's not cover your full region, then we need to move to the reducer. We need to use at the mean, median for getting the whole boundary or getting the fully covered area of this dataset. Okay.
Okay, so like you are talking that The 23 images, they are representing the Bangladesh, the whole Bangladesh area. But if you want to represent the whole Bangladesh, you have to work with these 23
Yeah,
23 images, different images.
yeah.
So
For
you are
the
just
whole, we can get the whole Bangladesh. We can get the 23
Mhm.
images because here I use here the 1 year, and 1 year we can get the total 23 images because every 16-day time period. Okay, 16-day
Yes.
interval time period.
Yeah.
Okay.
Okay. And another question about the visualization parameters.
Yeah.
Yeah, we always just copy it from the image, or maybe we can create it by
Yeah, you can
ourselves.
also create it, no problem. I'll also try to show you this part in this time, how you can easily create this. When I reprojected this scale value and try to
Mhm,
show you
mhm.
that how you can easily reproject it, you can add your own color. Okay, you can add your
Okay.
own visualization parameter in here. So I also try to show you this. Okay, so no problem for this.
Okay.
Okay,
Thank you.
so in this time you can see here I can get the result. This result is not appropriate. I get the result look like this, but I need the result -1 to +1. Okay, so for this I need to reproject the scale value, and here you can see they already provide the scale value. You can see 0.0001. Okay, so this is my scale. In this time here I can get total 23 images. 23 images I want to get in here. So all of the images, total 23 images, I need to multiply with this scale value. Then it reprojected, and I can get the result -1 to +1. So in this time, my main goal is that I need to reproject it scale value. So that's why this scale value I need to multiply with the total 23 images. Okay. So in this time, if you want to get the single image one by one, it's take a time. But when I use the function, so we can easily get this because function reuse our code. So let's go. I create a function. The same process you can see. So okay, I simply take a variable in here. Suppose this variable name is the scaled ndvi. You can put any variable name. Okay. Okay. So in this time, I take a function variable name. Okay. Okay. So now you can see here, I simply take a function variable name scaled ndvi, and this scale ndvi. So in this time, you can see I create a function. So that's why I simply use at the function keyword. Function keyword. Okay. And then in this time, I need to add here element. Suppose in this time, 23 images I take only for the one image. So I simply use at the one image and put the element name is the only for the image. Only I take the only for the one image. Okay. And this image I need to multiply with this scale factor 0.0001. Okay. So I simply use at the curly bracket. Okay. In this time I use at the return function. Okay. In this time I use the return function and return this image is multiply with my scale factor 0.0001. Okay. In this time you can see I take only for the one image, not all of the image. I take only for the one image. Okay. And then multiply with my scale factor. In this time I use anything, so that's why it copy their properties and apply all of the images. Okay. So you can see now this image is multiplied with this scale factor. So now it changed their properties, and these properties I want to also apply all of the images. Which image is the available between this time period, I want to apply it. So that's why I need to use a function. It's called the copy properties. So I simply use here copy properties. Okay. Then which element I want to copy it? I want to copy it, this element name image. Okay. And then I need to set here a system time start and system time in. You can see here I already, this is my system in this code. Here I already put a time period. This is my system time start and system time end. Okay, so in this time I simply take a element name image, only single image. This single image I multiply with my scale factor. Okay, and then I copy these properties and apply all of the image, which image is available between this system time start and system time end. Okay, so anyone any question about this? You can ask me. Anyone any question in here?
Yep.
Yeah.
One question.
Yeah.
Yes.
So, like, for the system time start and
Yeah.
system time end, can we just simply put the time period just
No.
written on the? Okay.
Because in this time I already defined this is my system. This system I already
Okay.
put my start date and end date. Okay, so that's why this is the rule. Okay, so that's why I need to put here the system. This system is already start time available, already in time is available. Between this time,
Okay.
all of the image I copy the properties. So in this time, all of the image multiply with the 0.001 because I use at the system time start and system time end. So in this time, whole code, all of the code, it's called the system. And this system has, I already defined a time period, start time and end time.
Okay.
Okay. In this time, here you can see these 23 images and this function. There is the no connection. There is a no connectivity. You can see this is the separate line of code and this is the another separate line of code. Okay, there is a no connection. In this time, I want to add. Anyhow, I want to add this connection. I make a connection with filter date because filter date has stored total 23 images. Okay. Otherwise, you can see it's totally separate code and it also another separate code. There is a no connection. Okay. So in this time, I simply copy the filter date variable name. Simply copy and paste here. Okay. After this, I simply use a function. It's called the map function. So I simply use the map function. So mainly this map function is connecting which function I created, connecting with my whole collection 23. I start the parenthesis and also in here the parenthesis. Okay. So now it's okay. Okay. Now these 23 images, all of the images, not only but 23, all of the images. I get only for the 1 year so that I can get the 23 images. So there's a lot of images. At the same time, I reprojected using this function. Okay, so this is the process for scale NDVI. And when you work with the land surface temperature monitoring, then also you can see we need to calculate it from the Kelvin to degree Celsius. We apply the same function, just we need to change the equation like this. What is the Kelvin to degree Celsius conversion formula? We just use the formula and otherwise all of the things will be same. I also try to show it in this part, no problem. So we also covered the LST also in here in this online training program. Okay, so in this time here you can see I can get the result look like this. In this time I want to check after the reprojected how many images I want to get. So let's go. I simply print this scale NDVI and use here the size function and click to the run. Oh, sorry, and click to the run. So now I can check our console tab. Here I can find 23 images, same. Okay, but in this time I reprojected this scale value because I multiply with my scale value all of the images. Okay, in this time
Please, Rahman,
yeah,
I have two questions. I have
any
two
question?
questions.
Yeah,
Yeah.
sorry, voice is very slow.
Yeah, can you come back to the script?
Yeah, I did not hear you properly.
Yeah. Anyway, just come back to the script. I want to show you something.
You want to change?
No, I don't see the script. Just you come back to the script.
You did not
and,
see my skin?
No, I don't see. Yes, now it's okay.
Yeah, okay.
Concerning the first question is concerning the system's time start and system time end. Is it already existing in the metadata of MODIS?
Yeah.
I mean, if we change, for example, one sensor to another sensor, VIRS, for example, or Sentinel. I think because I see it's a string, I think it's a particular of modus, this one. System time. If, for example, imagine that is a Sentinel too. So maybe to define the time start and the time end, we write in different way, isn't it? Not system time start and system time end.
So in this time, okay.
Yeah.
So in this time, in this code here, you can see I need to reproject it all of the images. Okay, I need to reproject it total 23 images. But in this time, I use only for the one element name. You can see image. Okay, only use one element. Okay, but rest of the image, how I can reproject it?
No, yes, I see your point. But for me, my question is about the system dot time start and time end. Is it only particular for modus images?
No, not for modus. All of the satellite images you can use here, no problem.
Is the same way we write system time start and system time end.
Yeah. So system time start and system time end is that connecting with this code. Okay. So here you can see I use at the system time start. It means that in this system, in this code, what is the time period start, and in this time, what is the time period end? Okay. Between this time period, all of the images, between this time period, how many images available? 23.
Okay.
And now this 23 image is the multiplier with this 0.0001. Just it. Okay. And system time start.
You mean in this code? You mean in this code?
Yeah.
Is not. Yeah. Thank you.
Okay.
My second question, Rahman, is about image. Image is not declared. So does the code know what does it mean image?
I don't understand.
You see function. You say function.
Yeah, function.
And being between between parentheses image for your first image, you said, or for one image. Image is not defined before.
It's
you
not.
Don't know what does it mean image? Is the code knows what is image?
Okay.
How?
Okay, I understand. Okay. So in this time you can see it's not defined. Your question is right. But when I use here the filter date and use here the map function, then it's defined. Okay, because filter date is already stored total 23 images. Okay, so if you want, you can use here the filter date, then use here the map function, and then create this function. It's also okay, no problem. But for easily understanding, first of all, I use here the image, okay, without any connection with the total 23 images. After I creating this code, then I simply connect with my filter date, because filter date is stored at total 23 images. Okay, and this total 23 images I need to reproject it. Okay.
So if you write without filter date, I mean, as you did it at the beginning, scale it and DVI is equal to function of image and return image multiplied by the scale factor. So it will be return nothing, because he will not understand what is image. But now, if you put filter date dot map, he will understand that you are talking as a variable from filter date.
Yeah, that's right. Yeah.
Okay, thank you.
Okay, so I hope you can get this all of the things clear now. Yeah, all of the things now clear.
Yes.
Okay.
Yes, thank you.
Okay. So now you can see I created this function, and all of the things I want to store it in a variable scale and DVI. Okay. So in this time, this scale and DVI, here also 23 images is available. In this time, when I reduce the image collection, I use here the scale and DVI total 23 images. Okay. So I simply copy and paste here instead of the filter date. In this time, this scale and DVI 23 images, and this 23 images is reprojected. I want to use the reprojected image for creating the average result or creating the reducing result. and then click to the run. Now you can check what happened I want to get. So you can see now I can totally get a white color map. Okay, so this white color map is appeared because my visualization code is not right in this time. You can see I want to show the result from the 0 pixel of NDVI up to 8000, but I already reprojected it. Okay, so that's why I need to change it. So I simply change it, our range -1 to +1. In this time I also not get the proper result. You can see it's showing the lot of green color because they are already provide this code. So I also need to change the color. So I simply remove all of the color. Okay, so I need to change the color and put the color according to my way. So I simply use at the suppose blue color, then use at the suppose white color, and then use at the such as suppose green color. Which pixel value is the negative or it's showing the blue, greater than showing the white, greater than it's showing the green. So let's guys simply click to the run. So now it creating the 3 color combination. Okay, okay, so you can see this is the dense vegetation. I want to check it, the inspector tab, what's the value I want to get. You can check, I can get the 0.7. okay, NDVI. I simply click here 0.8. okay, I check from here negative. Okay, that is the no vegetation. So in this time I want to check the another result, suppose such as I again move to the Saudi Arabia region. So now I can check the map. We can get the very less vegetation region. Suppose we can get the some vegetation in here. You can see I think some cropland or other things in here. Okay, otherwise you can simply all of the things will be not vegetation. You can take 0.5. so now we can get the result according to our range -1 to +1. okay, and this is our map of the Saudi Arabia NDVI map for year of 2021. okay, so now this map I create, and now I need to export this map. I also try to show the later when I export the satellite image, because satellite image and this type of image the same process for exporting. okay, so let's go. In this time I try to talk about that how you can easily filtering the satellite image, and then when I talk about the exporting, the same time I also try to show you the NDVI map, how you can easily export, because any types of images when you want to export, the same process. It can be land use land cover map, it can be NDVI map, NDWI map, Landsat image, Sentinel image, all of the things will be same. okay, so I also try to show you this part in here, then also try discuss in also in here, then you can easily relate it to things and easily understand. okay, so let's go. So in this time anyone in question about this code, you can ask me for creating the NDVI map using the MODIS data. Anyone any question?
If in the image we can find the cloud, what we can do?
Yeah,
If in the image we can find cloud, what can we do?
this image is already cloud removed. okay, so already all of the cloud, all of the haze, all of the things already removed in here. okay,
If we use another data,
yeah, so when you want to use here the Landsat Sentinel image for making the NDVI map, then you can also send the cloud in here, then we can easily remove the cloud in using the Google Earth Engine platform. I also try to show the all of the process for how you can easily remove the cloud from here. okay, but in this time this when you use the MODIS satellite NDVI data, this data MODIS NDVI data is already remove all of the cloud and haze, and you can check that their description, then you can easily understand how they create the data set. All of the things we can easily get from here. okay, you can see already marks for the water, cloud, heavy, aerosol, cloud, shadow, already all of the things will be marked. So there is a nothing chance to add it here, the cloud or water or other things is not added in here. We can get the very clear set image NDVI map when I use this data set. okay,
for calculating the EVI is the same process?
the same process, just you need to change the band value, band name. Okay.
Okay.
So I try to show you only for the one data set, but you also try to show not only for the NDVI. So all of the data set, you can see there are a lot of data set. You can see evapotranspiration data set. Simply click to here. You can see this data set is the 8 day. So we can get the every 8-day intervals data set. So you can easily you can see there also a band. You can see ET, total evapotranspiration. Okay. So which data set you want to need according to your research paper, you can get all of the dataset from the Google Earth Engine platform. Okay, and you can easily make the map, time series chart, or all of the dataset using easily. So here you can see they also provide the scale 0.1. So mainly they are provide the scale. So when you want to reproject it, this scale value is just multiply the same process. Then you can get the result. Okay, as well as also you can see a lot of dataset will be available in here. Okay, so which dataset you want to need, you can simply open the dataset and try to filter the all of the things will be same for filtering, showing all of the things will be same. And later I also try to show you that how you can easily export this map, and exporting is also same. Okay, so let's go. Okay, so in this time I try to discuss about, I completed all of the things step by step. How to import all of the import the Earth Engine dataset, how to filter this data, how to reduce this image collection, how to clip on your shapefile, how to display the result on the map, how to reproject it the scale pixel value. So we'll cover all of the things. So in this time, okay, before the time series chart, I try to discuss about the visual how we can easily filtering and visualizing the satellite images. Then we move to the time series chart. Okay, so let's go. So in this time, filtering and visualizing the satellite images in Google Earth Engine platform. So mainly when you want to filter the satellite image, it can be Landsat or Sentinel. It's depend on some factor. Suppose first factor is that your region. Suppose you want to need the Landsat satellite imagery for Dhaka city. So this region is a one factor. Then image properties. Suppose you want to need this image, which image will be not more than 1% cloud cover. You want to need only for this image. So this is the another factor. Suppose you want to need this satellite image for any specific time period. Year of 2017, year of 2017 winter, year of 2017 rainy season or summer season. So it's totally depend on your research work. Okay. So in this time, when you want to filter the satellite images, we just follow all of the process step by step. So filtering our region, it can be shapefile, your country boundary shapefile or Dhaka city shapefile, or which region you want to need the satellite images. You need to import the shapefile first of all. Then you need to filter the image properties. Suppose I want to need only for this image, which image will be not more than 1% cloud cover. So this is the one factor. And then you also need to filter the image for any specific time period. Okay, so let's go code editor and try to show the practically for working with the. Okay, so I simply open a new code editor. Okay, suppose in this time I want to work with the Dhaka city region. Suppose I want to need the Landsat images for the Dhaka city region. So first of all, I simply click on the asset tab and I simply import my shapefile of Dhaka city shapefile. I simply import the shapefile and I simply change it. I put the name is that ROI. Okay, and then I simply put here I show the layer. Map.add layer and use here the ROI and also focus the center of the shapefile. I simply use here the map.center object and put here the ROI and use here the suppose 10 and click to run. So now you can see here I can get this region. Suppose this region I want to need a Landsat 8 satellite imagery for any specific time period. Okay, so for this I simply go to the image collection and click on the Landsat because I want to work with the Landsat. Okay, and then you can see all of the image Landsat 9, Landsat 8, Landsat 7, all of the things will be same for filtering and visualizing the satellite images. All of the things will be same. Okay, so I also try to show the Landsat 8, but you also try to for the Landsat 7, Landsat 9, Landsat 5, all of the images you also try for your own work. So in this time, I want to work with the Landsat 9. I simply click on the Landsat 9. So now I can get all of the Landsat image collection, surface reflectance, top of atmospheric raw image. Which is image you want to need, you can simply work with this, but all of the things will be same. Okay, for filtering and visualizing the satellite image. In this time, I want to work with the top of atmospheric image. So then you can see I can get the image availability date for the Landsat 8 between this time. Then Earth Engine snippet dataset provided USGS and Google, and you can get all of the description about this dataset. Then you can get all of the band value, band name, pixel size, and wavelength. Okay, so in this time I want to work with this satellite images. So first of all, I need to import the satellite images. For importing, I just simply copy the same process. I simply copy and then paste in my code editor, and then give a variable name. The same process. Take a variable name and put the name is L8. You can put any name. In this time, the full image collection is stored in a variable L8. Okay, so now I want to check how many images are available for the whole world between the time period year of 2013 to 2021 November 9. I want to check it how many images are available. So for this, I just simply use the print function and then call the L8, because in this time L8 is stored all of the satellite images for the Landsat 8 top of atmospheric. I simply use the size function and click to the run. So now you can see number computing how many images are available for the whole world. So it's working. So here I can get a lot of images. So that's why it takes some time for it computing. Okay. Okay, so now you can see here I can get the lot of satellite images, more than 1 million satellite images I want to get. Okay, so in this time you can see I get this image collection, large number of image collection for the whole world, but I don't need for the whole world images. I want to need only for the image for the Dhaka city region. I don't need for the whole world. Okay, so in this time I use a function, so that's why this function get only for those images which images are available for the Dhaka city, not for the whole world, because this is a large number of collection. This large number of collection somehow I need to filter. Okay, so first of all I need filter according to my region. Okay, in this time I don't need for the whole world, I need only for the Dhaka city. I need this satellite image only for the Dhaka city. Okay, so let's go. I simply take a variable. Suppose this variable name is that filter region. Okay, in this time this large number of image collection is stored in a variable. This variable name is the L8. I simply copy and paste here. Okay, then I simply use a function. It's called the filter bounds. So mainly filter bounds is a function. It intersecting with the full collection with your region of interest. So in this time my full collection is the L8, but in this time I filter my boundary. I don't need for the whole world. I need this L8. I need this Landsat image collection only for my region, only for, and you can say geometry. So in this time, what is my geometry? Geometry is the shapefile variable name. And what is the shapefile variable name? ROI. I simply use here the ROI. Okay. So now I check how many images are available for my own for the Dhaka city. I want to check it. So I simply use here the print function again. Print and then simply call the filter region. Simply copy and paste here and use here the size function and click to the run. So now you can check how many images I want to get. I want to get for the Dhaka city 386 images. And what is the time duration? This time duration is that 2013 to present time. I want to get 386 images.
Sorry, Rahman.
Yeah.
Okay, now is okay. The screen was not changing. Okay, now.
Yeah, any question? Hello? Anyone, any question?
Your skin got stuck. Like maybe you had network issues. That's why like your skin got stuck, and then now it's okay.
Okay.
Yeah, could you please again describe the filter region variable?
Okay. So first of all, you can see filter bounds. This is a function. I can get the satellite image. You see, more than 1 million images, large number of collection. This large number of collection, I need to filter. This image collection is for the whole world. But in this time, I don't need for the whole world. I want to need this satellite image only for the Dhaka city. Okay. So that's why I simply use the filter bounds function. And I use the L8. So now this L8 is intersecting only for the Dhaka city region. So mainly you can check it. I simply copy and then I simply open the docs tab. Filter bounds. What is the, you can see mainly it intersection with geometry. Okay. So in this time, I have a collection L8, lot of image collection I want to get. Okay. In this time, I need to intersecting with. So that's why this collection is only available for the given region or given geometry. Okay. So any function which you, when you want to not understand, you can simply copy this function and then simply search on the docs tab. Then you can get the more description about this function. Such as in this time, filter bounds, it's mainly intersection with geometry. Okay. In this time, this is my full image collection, more than 1 million. Okay. But in this time, I need this image collection, it intersecting with my region. When I use the filter bounds function, satellite image only for the Dhaka city. So I can get the Dhaka city images total 386 for this region between this time. Okay. Anyone, any question about the filter bounds?
Yes, Rahman, imagine that at the beginning you have a feature collection, not a geometry as you did. So
this
in this
image,
case, it
this
will
image
not work.
is
You
not
need to,
okay. In this
you
time,
need,
this image is not.
no, I mean,
Yeah. Okay.
you don't, your ROI is a feature collection, is not your a shapefile, is not a table, it's a feature collection. So you cannot use filter bounds unless you change your feature collection to geometry, isn't it?
Okay.
Or
So
even it works, filter bounds with feature collection as well.
Not feature collection, filter bounds, this argument is a geometry. And it is my image collection. Okay. This image collection, I intersect with my region.
Yeah. I'm talking about filter bounds. It works only with geometry, not with feature collection. This is my point.
So filter bounds is a function.
It works only.
Yeah.
Works only with geometry. It does not work with feature collection.
Okay, I don't understand again that filter bounds is a function. Mainly this function is intersection. In this time, I want to use here the image collection. I can get that all of the image collection for the whole world. My main target is that all of the image collection is intersecting with my region. And which my region, which images are available, I need to find out. Okay.
Yes. Imagine that your variable ROI is not a table. I mean, from your assets. Imagine imagine that you is derived from a feature collection, okay, from Gore, for example, or from any boundary layer existing in Google Earth. So in this case, can you use also the filter
Okay,
bounds
filter
as
bounds
well?
is only for the
possible?
geometry, not a feature collection. So in this time I not use the feature
Yes, this is
collection.
my point.
Yeah, is in this time I
Yes,
not
yes.
use here the feature collection. Okay, so I use
yeah.
the image
Okay,
collection.
okay.
Okay, so image collection means that it has a lot of images. You can see lot of images, more than 1 million images I want to get in here. Okay, in this time
Yes,
I
yes.
use the
This
filter
clearly.
bounds function. That's why in this time it intersecting with my region and appear only for this image which images are available for my region. Okay, and this is geometry, not a feature collection. You can see this argument is a geometry, and this L8 is the image collection. L8 is the image collection. Okay, image collection I with my region. So that's why in this time in my region Dhaka city which images are available I can get only for those images. Okay, and I check it for check it, I can get the result
okay,
386 images. Okay, and this 386 images has a lot of cloud cover, less than 1%, 2%, 3%, 5%, 10%, 90%. But I need only for those images which image is the less than, will not be more than 1% cloud cover. So in this time from 386 images I want to need only for those images which image will be not more than 1% cloud cover. So I need to filter image properties or image metadata. Okay, from the 386 images. Okay, from the 386 images I want to filter which image will be not more than 1% cloud cover. Okay, so let's go. I simply take a variable and put the variable name is that filter metadata. You can use any name, no problem. In this time this 386 images is stored in a variable. This variable name is the filter region, and then I simply paste here and I simply use a function. It's called the filter metadata. So mainly when you want to filter the image properties we are using the filter metadata. Okay, and then I check the value. You can see I can get all of the value. First of all the name, then operator, then value. So name, what is the name? Name is the image properties name. I can get the image properties. You can see in here all of the image properties I can easily get from here. Okay, a lot of image properties will be available in here. So in this time I want to need only for the one cloud cover. So you also try to check the other properties, no problem. So in this time I use the cloud cover. I simply copy the cloud cover and then I simply use here cloud cover. Then use here the operator. I simply put the operator is the less than. So I simply use here the less than. I set the value for 1. Okay, in this time I want to check how many images are available for the region of Dhaka city which image will be not more than 1% cloud cover. I want to check it. So for this I simply use here the print function and then I simply call the filter metadata and use here the size function. Okay, and click to the run. So now you can check how many images are available, which image is the less than 1%. I can get the 57 images. Okay, in this time I want to check, supposing it is less than 5%, then this value is also increasing. Okay, you can see 92. So I want to need the less than 1% cloud cover images only for. I want to use here 1%. Okay, sometime you can use here the less than 1%, but you did not find out the any image. Suppose you want to work with the any types of the coastal area or coastal region where the cloud is available. You want to use here the 1, but you did not find any image. You can get the 0. It means that for this region less than 1% cloud cover image is not available. Okay, so then you also need to increasing the value, then you can get the images. Okay, okay, so in this time I get the only for the 1 images. Okay, and 57 images between this time period, but I need this satellite image for a specific time period for year of 2021. Okay, so for this I take another, so I simply take another variable, suppose filter date, and then you can see 57 image is available, stored in a variable. What's the variable? Filter metadata. I simply copy and paste here and use a function. It's called the filter date. Put here the first date and in date. I simply put here the first date is that year of 2021. Okay, and then I simply put here the 2021 December 31. You can put your own time period. Okay, in this time I want to check how many images are available for the year of 2021. I simply use here the print function and then call the filter date and use here the size function and click to the run. So now you can see I can get only for the 4 images. Okay, so mainly you can see, first of all, first time I can get that more than 1 million images. Then I filter it according to my region of Dhaka city. I can get 386. Then I also filter it according to the image properties. I want to need only for this image whose image will be not more than 1% cloud cover. I can find out 57 images. From the 57 images, I want to need only for this image whose images are available for year of 2021. I can get only for the 4 images. So it's the filtering process. Okay, so anyone any question about this process, you can ask me now. Any question for the filtering process? Yeah,
one question, like, so the difference between the Modi's data and the Lancet data, like for the Modi's data we don't have to filter the images for cloud cover, and for the Lancet we have to what's called the filter the images which are cloud cover less than 1, right?
yeah, because Modis, you can check the properties. If the properties is also available for the Modis NDVI, you can use it. Otherwise, don't need use. Okay, so I can check the image properties. I can get the cloud cover, so I can easily filter it. But you can Modis NDVI, there is a nothing option for the image properties or other things is not available. Okay.
Okay. So it's depend on the image you are working with.
Okay, so in this time here you can say I can get total 4 images. I want to know what is the image acquisition date or image time period. I need to check it. Okay, because between this time period, this image is not captured at the same time. Okay, so I want to check it. So for this, I simply use only for the print function and then call the filter date and just click to the run.